In this video, we will understand peer-to-peer networks, how files are distributed in a peer-to-peer system, and how BitTorrent makes the file sharing fast and efficient. So let us start. Imagine this. You want to download a very large file. Maybe it is a new version of Windows, a movie, or a software update. Now, normally, how does this happen? In the traditional method, everything depends on one central server. That server stores the file, and every user like you, me, and thousands of others downloads it directly from that server. This sounds simple, right? But here is the problem. What if 10,000 people try to download the same file at the same time? The server gets overloaded. Downloads become very slow, and the server needs huge bandwidth to handle all those requests. So basically, one server is doing all the hard work. This type of architecture is called the client-server model. Now, let's flip the idea. What if instead of one server doing all the work, everyone helps each other? This is exactly what peer-to-peer or P2P network does. In a peer-to-peer network, every user is called a peer, and a peer can do two things at the same time. It can download and it can also upload. That means once someone receives part of the file, they can immediately start sharing it with others. So, instead of one server sending the file to everyone, people start helping each other. One person says, "I have this part of the file, take it from me." Another says, "I have another part, take it from me." And slowly, everyone gets the complete file much faster. Let's understand this with a simple real-life example. Imagine a classroom. The teacher has 100 copies of notes. In the client-server model, every student goes to the teacher one by one to get the notes. The result is the teacher gets tired, students have to wait, and the whole process is slow. But in the peer-to-peer model, the teacher gives notes to a few students first. Those students share them with others, and soon everyone gets the notes much faster. This is why peer-to-peer becomes faster as more people join, because more users means more sharing, and more sharing means faster downloads. This property is called self-scalability. Now, the most famous real-world example of peer-to-peer file sharing is BitTorrent, and it works in a very smart way. Instead of sending one big file as a whole, BitTorrent breaks that file into small pieces called chunks. Different peers download different chunks. Then they exchange those chunks with each other. So, instead of downloading from one place, you download different parts from different people at the same time. And that is why torrents are often so fast. Now, let's go a little deeper. So far, peer-to-peer looks better, but let's not just assume it. Let's compare both systems mathematically and see how download time changes as more users join. Let's create a simple situation. Imagine there is a server that has a file. The size of that file is f, and there are n users or peers who want this file. Now, every device has two speeds: an upload speed, which tells how fast it can send data, and a download speed, which tells how fast it can receive data. We denote server's upload speed as US. Each peer's upload speed as U1, U2, U3, and so on. and each peer's download speed as D1, D2, D3 and so on. Our goal is simple. We want to find out how much time it takes to distribute the file to everyone. This is called the distribution time. Let's first look at the client-server model. In this model, peers do nothing except download. So, the server has to send the file separately to every user. That means total data sent by the server is n multiplied by f. Now, there are two limits here. The first limit is the server limit. The server has to upload n copies of the file. So, the minimum time needed is nf divided by us. This means bigger file means more time, and more users means more time, and faster server means less time. The second limit is the slowest user limit. Think about the user with the slow internet speed. Even if the server is super fast, that slow user will still take time. So, the minimum time here is f divided by d minimum, where d minimum is the slowest download speed. So, the final distribution time in client-server model is the maximum of these two values. And what does this tell us? As the number of users increases, the time increases linearly. So, if users increase 1000 times, the time also increases 1000 times. That is why large downloads become slow and servers crash during high demand, because the server is doing all the work alone. Now, let's look at the peer-to-peer model. Here comes the twist. Users don't just download, they also upload and help others. Again, there are some limits. The first is the server still has to start. Initially, only the server has the file, so it must send at least one full copy. That takes f divided by us time. The second is the slowest user limit. Same as before, that is f divided by d minimum. And now comes the magic. In the peer-to-peer system, the server uploads and peers also upload. So, total upload power becomes us plus u1 plus u2 plus u3 up to un. This means the time becomes nf divided by total upload capacity. So, the final distribution time in P2P is the maximum of these three values. Now, compare the two systems. In client server, more users means more load, and more load means more delay. But in P2P, more user means more helpers. So, the distribution time increases very slowly. Sometimes it almost stays constant. That is why peer-to-peer network is called a self-scalable system. Now, let's talk about how BitTorrent actually works in real life. BitTorrent is a peer-to-peer file sharing system. Instead of downloading a file from one place, you download it from many people at the same time. The big file is divided into small pieces called chunks, and different peers have different chunks. The collection of all peers sharing one file is called a torrent. For example, if 100 people are sharing the same movie, that whole group is one torrent. Now, you might wonder, how do you find other peers? That's where something called a tracker comes in. A tracker is like a coordinator. It keeps a list of active peers and helps new users connect to others. Let's follow an example. Suppose a new user joins. His name is Rav. Here's what happens step by step. First, Rav decides to download a file. So, he joins the torrent. The moment he joins, he registers himself with the tracker. This means he tells the tracker, "Hey, I am here and I want this file." The tracker then adds Rav's name to the list of active peers participating in that torrent. But this is not a one-time thing. Rav periodically sends small updates to the tracker saying, "I am still here." This helps the tracker maintain an updated list of peers who are currently online and participating. Now, the tracker replies back to Rav with the list of other active peers. Let's say it gives him the address of 50 peers. Rav tries to connect to some of them. These connected peers are called his neighboring peers. Now, the important thing is, Rav is not just downloading, he is also uploading at the same time. He downloads chunks from others and uploads chunks he already has. This is what makes peer-to-peer powerful. Now, Rav has to make two smart decisions. The first decision is, which chunks should he download first? BitTorrent uses a smart strategy called Rarest first. This means Rav finds the chunk that the fewest people have and downloads that first. Why? Because it prevents rare chunks from disappearing and keeps all chunks available in the network. The second decision is, whom should he upload to? Rav cannot upload to everyone, so BitTorrent uses another smart strategy called Tit-for-Tat. This simply means, you help me, I help you. Rav gives priority to those peers who are sending him the data the fastest. He chooses the top 4 such peers and sends data to them. These are called unchoked peers. But what about new users who have nothing to share yet? BitTorrent solves this too. Every 30 seconds, Rav randomly picks one extra peer and sends data to that peer. This is called optimistic unchoking. This helps new users get started and also helps discover better peers. The whole system is dynamic. Peers keep joining, peers keep leaving, upload speeds change, connections change, so BitTorrent continuously adjusts and optimizes sharing. And this is why BitTorrent is not just file sharing, it is a smart cooperation system where everyone shares and everyone benefits. The biggest idea to remember is that BitTorrent works because people don't just download, they also help distribute the file. And if people only downloaded and never uploaded, the whole system would collapse. That is why BitTorrent uses incentives like Tit-for-Tat. So, the next time you download a torrent, remember this: you are not just a user, you are a part of a network, helping others too. Thanks for watching.